Hi, I'm Tony from Humpop Gaming. If you've spent any time trying to learn OOP, or you've watched my previous video on the basics of object-oriented programming, then you'll have heard of the concept of composition over inheritance. Today, we're going to look at what that means, how it applies to your code, and when to use it. If you want to create a better, more robust, flexible code base, stay until the end as I have some extra hints and tips for you so you can achieve just this. If you've not watched my previous video about getting started with OOP, I recommend you do so before starting this video, as I'm going to assume that you're already familiar with object-oriented programming. In the previous video, we looked at the core principles of object-oriented programming: encapsulation, abstraction, inheritance, and polymorphism. Following these concepts, we're able to modularize our code, so making it easier to change, reduce complexity, so it allows us to focus on what matters, enable code reuse through the logical separation of our code, and make the code easier to extend. Or another way of saying that is so we can add more functionality. Now, all that good stuff comes from us being able to inherit from the parent class. But what happens when inheritance starts to cause more complications than it solves? Let's look at how that can start to cause us problems. We're going to look at the code from the previous video and consider how we'd use this for a transport-based game. So let's start with a vehicle. I'll talk you through it, and then we can start to change it later. Now, this code structure has been built using an inheritance-based code structure. This vehicle acts as the base class. I've kept the functionality to a minimum, as I want to be able to reuse this in the code base. It's going to be here where I implement additional types of vehicle. So apart from our new functionality, I've also added the ability for the vehicle to start and stop, accelerate and brake, because this is something that I want all vehicles in my game to be able to do. Next, I've added a car, which is a type of vehicle, as this extends the vehicle, which we can see here. It gets all of its methods and properties that are found on the parent class, but I've also added one more for the car, and that's check tyre pressure. It's more suited here than on the vehicle, as I want to add a boat to my game later, and this functionality is redundant for that type of vehicle. Now you might ask, why not just add check tyre pressure to the vehicle and be done with it? If you implement a boat, it doesn't really matter, you just wouldn't use it. But it's important to only have the methods and properties that are relevant to that class, because any class that extends them will also get access to these methods and properties, and having something that's there which doesn't belong there could cause bugs. It could cause confusion, it'll make it difficult to maintain in the future. It may even mean that the child class has to override and handle a method that they don't really need. And as a side note, it's worth knowing that there's a principle in software development that applies to this, and that principle is called solid. And the bit that we're talking about here is the L in solid, and that's Liskov's substitution principle. I'm not going to go into that now, but if you want me to do a video on solid principles and how you can use them to make a more robust code base, let me know in the comments. Following on from the car, I had a specific type of car, a Ferrari and a Porsche. Now, it's in these where I'd be able to add Ferrari-specific functionality or Porsche-specific functionality. Finally, I create a specific make of Ferrari and a specific make of Porsche. So here, we have an F8 and a Porsche 911. Having the code structure like this means it's really easy to implement different makes and models of cars, as they all inherit the functionality from the parent classes. Next, I add a script to instantiate the F8 and the 911. I run the script, and it all works as expected. So that's got to be a good thing, right? Each class now encapsulates its own functionality, the code works, so what's the problem? It meets the core concepts of OOP. This should mean that it's flexible, extensible, and easy to understand, but it's not. Keeping track of all these variables and what ultimately gets up to the vehicle is just hard work, and it's ultimately error-prone. Adding functionality to the base class could have unintended side effects on the child classes, making our base class brittle. What if I wanted to add a flying Ferrari or a flying Porsche to the game? Where do these go? Well, I could put them here, but now I've got this fly and land functionality, which is also needed in our flying Porsche. So this means code duplication in the Porsche script, or we need to inherit something else to avoid that duplication. This is just getting hard to maintain. What we have here is a big red flag. So how can we resolve it? Well, I'm sure you've already worked out that the answer is going to be composition. Before we jump into refactoring the code, let's take a look at what composition is. So it's important to understand that the F8 is a type of Ferrari, which in turn is a type of car, and in turn is a type of vehicle. So we can say the F8 is a type of vehicle, but it's also a type of car and a type of Ferrari. It's all of these things. Composing a class causes us to think differently about our code. So instead of saying the F8 is a Ferrari, we will say the F8 has an engine, or the F8 has a manufacturer, or the F8 has a set of wheels. It's the combination of the things that go into a car class which will make the specific type of class which we're interested in this case, an F8 Ferrari. All of this sounds a little bit odd, so let's look at the code to understand it. So I've just said three things that the F8 would have, is an engine, a manufacturer, and a set of wheels. Let's start off by creating the manufacturer. We also want it to have an engine. In here we'll add the functionality relating to the engine, as well as a check to identify that the engine is running. Our car also needs wheels, so we're going to create a wheel class. This is going to contain make, pressure, and compound, and a method to check that the individual tyre has not lost any pressure. What we have now is a car that has a manufacturer, has an engine, and has a set of wheels. By composing our model, we have a richer set of data and have a more flexible design, all while being easier to read and ultimately maintain. In the car, I've added the ability to start and stop the car, which ultimately calls the engine start and stop functionality. Accelerate and brake is provided, as well as the ability to check for any pressure loss. You'll probably notice that this functionality is a little more fully fledged than the inheritance example, and that's simply because it feels easier to build up a model when there isn't multiple layers involved. We now have a set of models that are easy to extend and maintain. There's no need to traverse up a class tree and keep track of all the variables that are being passed through. Now in the main script, I'll delete my current script and we're going to build the car that I want. Now you could move these specific implementations of a car into their own module script, but I'll leave that one up to you. And then we can do the same with the Porsche and call the associated methods. And we run it and I get an error. Let's check out what it is. So the error's on the car script on line 24. It can't add on nil, and that would be because I haven't added a speed property in here and set its initial value. So we've run it again, and everything works as expected. Our Ferrari starts, it accelerates, it stops, and then we do the same with the Porsche. This is great. We've got more flexible code. It's more readable. But how does a flying car fit in with this example? Well, I'm going to answer that question with another question. Does the flying car need to consume all the methods that are in our car? In this case, yes. It's just going to be a car with additional functionality of flying. So my next question before I choose how to structure the code is, given what we currently know about our game, is there ever going to be a scenario where there's going to be functionality added to our car that the flying car would not need access to? In this case, the answer is no. It's always going to be a car that's able to fly. As we've answered yes to both questions, does it need the current functionality of the car? And will it always need new functionality that the car will provide? Then we've identified a candidate for a child class. Following these questions should always guide you to the right answer. But remember, if there's even one method that shouldn't be consumed by the child, then it's a signal that composition is better suited. So let's create an additional class for something that would fly. We'll create a wing and pass in a length. What we'll do now is add in a new class under car. This will be our flying car. It'll take in the same parameter as the car with the addition of a max altitude and wings. We create a new instance of the car, passing the manufacturer, the engine, and the wheels. Then we set the wings and the max altitude properties. And then we set current altitude to 0. Then we create the fly method and the land method. And finally, we add the new instance of the flying car into the calling script. So now I've added new functionality to the calling script. Let's run it and see it working. Or not. Okay, so I've made a mistake here. Attempt to concatenate the table with a string. So this is saying the current altitude is a table, I think. But it's definitely not. Up here it's been current altitude is set to max altitude is being passed in. So if we go back to our calling script, it looks like I've passed something in incorrectly. I haven't, but I can see the problem. I'm passing with a colon, and you can see the new instance is with a dot. So if I change that, and I've done it all the way up here as well. And now we run it again, and we can see it's working perfectly fine. Flying at 1,000 meters, and now we're landing and we're at 0 meters. Having this structure and considering what functionality is needed by a class at some point in the future will help us maintain a clean code base, and it'll reduce the amount of bugs that we get. Remember, the goal of this is not to remove inheritance. Inheritance in itself is very powerful and very useful. What we're trying to do is ensure that our base classes don't become brittle and limit the amount of complexity in our code. If you want this code, I have it on my website. I've put a link in the description below. While you're there, remember to sign up to the email list if you want to keep up with what I'm doing or keep in touch with any changes that I make to the code. If you found this video useful, please like and subscribe. It really helps the channel, and by doing this, it'll allow me to cover more topics that you find interesting and make more videos that are higher quality. So please hit that subscribe button. We've seen that inheritance is often better suited when there's a clear is-a relationship. And if you're dealing with a is-a relationship that doesn't require much flexibility or change, inheritance might still be the way to go. But composition really shines when you need flexibility. When writing your code, always be open to refactoring it. If it seems complicated and scary to refactor, it's probably a strong indication that refactoring is really needed at this point. Writing quality code is an organic process. Your code will change as new things are added, and you'll learn better ways of doing things. Don't let getting it right the first time stop you from creating something. There's no such thing as the perfect code base. If you want to structure your code better, try new things. Learn different design patterns, as these will really help. I've created a full series on design patterns. Feel free to check them out. The link's in the description below. While you're there, remember to subscribe and hit that notification bell so you can get notified when new videos are released. And that's it. If you have any thoughts on what I've covered today, drop me a message in the comments. Thanks for watching and see you next time.